Hello there and welcome to this workshop on visualizing financial data with Python. Today we're going to be going through a set of concepts that will allow you to create visualizations, data visualizations that communicate insights about your data in the context of financial data or banking. So let's get started. Visit the description section of this video and then click on the practice resource link that will take you to this page, sign in, and then just click on continue learning and you should get to the sample notebook. I'll be using the practice notebook that will contain more challenges than the sample notebook. So if you would want to continue along deeper in this journey, be sure to think about becoming an After Work member and you'll get access to other resources. Right, so let's get started. Once we get to the notebook, run the prerequisites. So we'll import the pandas library, matplotlib, splt, and also seaborn, which we will also use to create some advanced statistical visualizations. So once you have done that, we can get started with the first concept. So the first concept entails creating line charts. Line charts allow us to be able to identify just trends, patterns within our data. And if we had this data set that contains information about just stocks data, initially we would first of all prepare the data set so that we can create a line chart. So in Python, we would need to ensure that the columns have maybe some specific data type that we need. Like for instance, for the date column, we would ensure that it has a date time format. And then we can also set it to be the index column and then use that for our analysis later onwards. So in our case, we have this data, which you can see here now we have the date column is the index column, then we have the rest of the data here. So to create a line chart, we can first of all use PLT, which is matplotlib. So from the matplotlib library, and then we set we use the figure function to set the dimensions of the figure. Fig size is the parameter that we use, and then we give that parameter a value that's going to be a tuple. What will be the first element in that tuple, that's 12, would be the dimensions, the horizontal or the x-axis dimensions, and on the second parameter would be the y-axis dimensions. And then we use the plot function to set the data or to create the line plot. So the first parameter that we give, or the first argument, would be the x, what would go on the x-axis, which is the date column, and we reference it using index because it's now the index of our data frame. Then we set on the y-axis we want stock 1, and then we set the marker type for the visualizations. We don't need to set these ones, by the way, but we could always do that if we want. These are just some more attributes like the color of the line that we're going to have, as well as having a label in our plot. If we wanted to also include maybe stock 2, we would just include a new line. So if I copy that, I paste it below here, I can put maybe another line, now stock 2, and maybe change color from B to black to maybe red, and change this to stock 2. That's something that I could. Here I just add a title using the title function. The X label, that's the X, it's like labeling the X-axis and Y-axis as well. And also we can add a legend, which will just use the values that we have for the label here, and a grid, so that we have just squares in the background. And lastly, we use the show function to be able to display the plot. So if I run this, I should be able to see now the two plots that you see here. And I could decide even not to even include the markers if they're too much. So I could also remove that, and that would give me the lines that we see here. All right, pause the video and then work on the challenge. Moving on, histograms. In some other situations, we might want to understand the distribution of the numerical variables that we have. For instance, we might want to know how spread out the data is. Say, for example, for open price, is it towards maybe the lower end or the higher end, which might help us just answer some research questions. So first of all, we load the data which we have here. And for histogram, we normally work with one variable, one numerical variable. It's just continuous. And in our case, we'll just repeat the same thing. We set the size of our plot, but now for histogram, we use the hist function, and we pass the column that we want to work with as the first argument. Then we set bins, which will just have those different intervals within our histogram, which will define the intervals in our histogram. It will also help us be able to understand our distribution. We set the color of those bars within our histogram, and also the color of the edge of those bars to black. And here we just set the title, x-axis label, y-axis label. Those are just titles for the x-axis and y-axis. Then the grid, you can display that as well. And those also show. Here we're just setting that for the y-axis. We may not necessarily want to have a grid for all. Here we had a grid for both axes. But here we just want that for the y-axis. We can also set the transparency of that line, those lines, using this alpha parameter, and just set it to 0.75, slightly faded. So you can see here, and you can modify. Maybe if we put 0.2 for that, you should be able to see the effect, which is quite faded. Right, pause the video and then work on the challenge. In some other cases, we might want to identify outliers, or even just get the same information that we had in terms of distribution, but get more information in terms of measures of central tendency, like for example, mean, median. We can be able to do that using a box plot. So assuming we had this data set that we've loaded, that you can see here contains investments data. If we want to create maybe some sort of visualization that helps us to visualize the distribution and also tell us more about outliers, we can use a box plot. I'll just keep the remaining functions constant. I won't explain so much of those functions. I'll just explain the new function. So we can use a box plot function, and then we set aside DF investment. DF investment is the variable that we want to create a box plot for. And we also showcase some we provide some other details using the two parameters as patch artist and show means, which gives us just an idea of the means or the actual mean value within our plot. So this is our box plot. There's an outlier over here. Right, pause the video and then work on the challenge. Moving on, we might want to create a scatter plot, and a scatter plot would help us visualize the relationship between two numerical variables. So if we want to know whether, as maybe values of one variable increase, do the other values of the other variable increase, then we can use a scatter plot. So if this is our data set, we might want to, assuming this is our data set, we might want to maybe select, first of all, work with two variables, continuous variables. So it could be return rate and volatility. We want to check whether there's a relationship between those two. So we just select them, store them in these two variables, x and y. And then we just use the scatter function, and we set on the x-axis, we want the x variable, that's return date, and on the y-axis, we want volatility. We can set aside the points, the color of the points, and here we're setting it to be blue, sorry. And here we're also setting the transparency of those points by using the alpha parameter. The rest of the functions will just remain the same. I think we are already used to them. So there you go. Here we can see some sort of pattern that is return rate increases, so does also volatility, which means there's a positive relationship that both of those variables are correlated. Pause the video and then work on the challenge. Moving on, we can decide to create some sort of maybe pie chart. So if our intention is to maybe represent data in that visualization to show the proportions, we could decide first of all to create a summary table out of a bigger table. So here we have a bigger table which contains investment sector, investment amount, And to, as you can see here, to get the values of investment sector, we would need to use the index attribute. In the same case for investment amount, is values. But again, you could add a reset index and function over here so that you're able to work with just a pandas data frame and just be able to reference these as just normal columns. But yeah, let me just reverse that just for just understanding. So yeah, so once we get to do that, so our labels or categories will be what we have here, and our sizes will be what we have here. We then use the pie function to be able to plot our pie chart. We pass the values, so that's the sizes variable, and also the labels as the categories, or in our case, which will be here. And auto PCT, we'll just convert our percentages into one decimal place, and the starting angle to be 140 to rotate the pie chart to have the section that we want at a particular point. So if you run this and also run this, you should be able to see your visualization. So if you change maybe 140 to maybe 10, you'll note that, you know, the pie chart will be rotated to maybe have another section at the top. So you can see here we have finance and energy, but if I go back, I'll have technology at the top. All right, pause the video and then work on the challenge. Moving on, in some situations, we might want to maybe create some sort of bubble chart. A bubble chart is more like a scatter plot. It allows us again to show whether there's a relationship between just two numerical variables, but with a bubble chart, you also have the aspect of introducing a third variable that gives you much more information about the two variables that you have. So for instance, we can decide to, we can even have more than two. So so assuming we have these variables, X and Y, these are major variables, we can decide to just plot them in a bubble chart or more like a scatter plot, but then also introduce this size aspect, which simply means that the size of the dots will be reflective of some sort of insight, and as well as colors. So once we do that, we can now move on to just creating our bubble chart. We just use just a scatter plot function. So we can say scatter function. So we say X and Y, which are the ones that we want to plot. Then we set the size to be what we see here. Colors, we can also set it to be just market share, which is what we have here. But colors, we would have just different colors again based on market share. We set just how the color of the transparency of those colors, and also we can decide to use some sort of template for some colors. Edge colors, we could also set that to what we want. So of still the dots. So if you look at here, it's a bit faded, so you can even just lose out maybe alpha. Let's remove alpha, and we should be able to see, if this was to be quite bigger, we would see the edge of those dots, but they are reflective of what we see. So yeah, I think I've removed that as well. You can see the colors, the colors means market share is a bit lower, but market share is quite high. I could still remove that, but line width, we didn't need line width. Sorry guys, didn't need line width for that. I think what else? We can remove, okay, this color bar, this is the legend that we have just to tell us more about the market share, which again would tell us more of what is happening here. But yeah, that's just a bit about a bubble chart. Yep. Pause the video and then work on the challenge. All right, moving on, we can also create a pair plot to create multiple scatter plots all at once for the numerical variables that we have in our data set. So if we had this stock prices data, we might want to create a pair plot for open price, close price, high price, low price, volume, market cap, P ratio, dividend, and 52-week high. So this would be variables that we want, and we can create a pair plot using the pair plot function. Yeah, and run that. And you'll note here we are not using plt.show, we're just using a semicolon over here. So we should get the just multiple scatter plots for those variables that I've mentioned, and also histograms for each of those ones. So might take a bit of some time, again depending on the size of the data set, and that generally should give you a good idea of the relationships between the variables, numerical variables that you have in your data, instead of just plotting one scatter plot after the other. So you can see here we have a pair plot, like for example this is just a histogram for open price, this is histogram for close price, but this visualization, it's close price versus, if you scroll down, you'll see open price. So you can see that, you know, those two particular, close price and open price, are directly proportional. If you scroll down, same case with high price and open price, low price and open price. But for volume, it's different. The same case with market cap, PE ratio, they're not necessarily correlated. All right, pause the video and then work on the challenge. Lastly, we're going to learn about how to create a bar chart still in Python when working with financial data. So assuming that we have these stock prices, we can set a bar chart would be, you would need some category and also some numerical data on. So you need two variables, one with just categorical information and another one with numerical information. So for instance, in our case, we have company, which is what we have here, APL prices, which is what we have here. So we can decide to create just a bar chart for both. So we just select those values, and then we can decide now to create a bar chart using the bar function. Then set the companies. Companies would be what we have here. Companies would be, in our case here, we have okay, yeah, so sorry. So companies is what we are going to have on the x-axis, and AAPL on the y-axis, color blue. This will be the colors of the bar charts. And then you just set these, the remaining functions for just some information that we need on the chart. Something we note that we introduce here, it's xticks. This just rotates the values on the x-axis to 45 degrees for easy readability, for readability purposes, and also tight layout to just ensure that the layout of the visualization is tightly packed, and we display that. Awesome. Pause the video and then work on the challenge. All right, and that's it. And that's it with regards to this learning experience. We hope that you're able to find it useful. In terms of the next steps, we would recommend you to maybe look at, if you really struggled maybe with something like data analysis, look into that, just being able to perform various data analysis techniques, because such as creating pivot tables or summary tables like we did, which just involves grouping of data, maybe filtering or data cleaning. Feel free to revisit some of the content that we have on that. The previous workshop or previous course that we would recommend that you go through before even coming into this is one that's focused on data cleaning and pre-processing in banking. So have a look at that. Next steps, possibly to now think about maybe creating dashboards using what we have already gone through, or even just creating interactive visualizations using a tool like Plotly. All right, all the best in your learning journey. See you in the next learning experience, in the next course. Bye-bye.